So today we're going to look at a mass balance for the fed batch process. So let's start with the basics. So for the mass balance, is the rate of accumulation of cells in the vessel is equal to rate of cells going into the vessel minus the rate of cells going out of the vessel plus the rate of cells generated inside the vessel. So here you can see a generic vessel with an input and an output. So here Q is the volumetric flow rate into the vessel and C is the concentration of cells going in. And here is the concentration of cells going out and the volumetric flow rate going out of the vessel. So for the fed batch process, let's express the formula in terms of an equation. So the rate of accumulation can be expressed by the change in mass of cells in the vessel, change being change in unit time, which is equal to the rate of input, minus the output, plus the growth. So different to the normal batch process, this isn't a closed system, so there is an input, but there is no output. So the output term can be cancelled. There is an input, but it is not cells, it's the feed substrate. So cells input is 0, so therefore that term can be cancelled as well. This leaves it with the rate of accumulation is equal to the rate of growth. Because there is an input, the volume is always changing, so we cannot take volume out of the equation and cancel it. However, we can express the equation in terms of specific growth rate. So we know specific growth rate is mu equals to rate of growth over the concentration of cells. So if we rearrange and substitute this back into the equation, we get rate of accumulation equals to V mu Cc. So this is the mass balance for a fed batch process.